Welcome back to this video. This video will see what this FLSM is. Stands for Fixed Length Subnet Mask. And then we'll learn when to use this FLSM, Fixed Length Subnet Mask, versus VLSM. VLSM is something that we learned in the last few videos. It's Variable Length Subnet Mask. So when to use FLSM, right? It's very simple. It is when your requirement is equal length, which means fixed length, otherwise known as fixed length. So example would be 4 departments that needs 50 hosts each. Okay, so what I mean by that is, let's say for IT department we need 50, finance 50, customer support 50, sales 50. This is a requirement. So they're all 50, right? So we don't need to go for VLSM. We can easily work with FLSM because they are fixed length or equal length, right? They're all equal. So our network ID, let's say, is 192.168.1.0/24. This is the network ID. We need to work this requirement from this ID. So notice this /24 here I put. This is the default subnet mask for class C. I'm using class C example here, right? So I know the 192 is class C address because it belongs to 192 to 224 range, right? So I hope you guys know the range. So 192 is in the range of 192 to 224. So that's why it's class C, and class C network bits is /24. What do you mean by network bits, right? So let's look at it real fast. I'm sure you know this, but just to review everything. So 192, right? I write 192 like this. Under 192, this is a first octet, right? This is a first octet. We have 8 bits. We know that in IPv4 there are total 32 bits. So this is the first 8 bits, right? And then we have a dot, right? Next octet 168. I put 168 here. We have another 8 bits. 1, 2, 3, 4, 5, 6, 7, 8 dot. Then this 1. Again 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Right? So this is 24. 8 plus 8 plus 8 equals 24. Now we know where this 24 coming from. Understood? This 24 is coming from the network bits. 8 plus 8 plus 8 equals 24. That's why putting it like this, /24 represents the network bits. Network bits. Okay, and then we have the 0, right? We have the 0 here. This is the host portion, and we have 8 zeros here. So we have to add that too. So we'll get total 32 bits. That's how we say 32 bits in IPv4 addressing. But the network bits in class C is 24. This is the default subnet mask. And you might have already seen there is a different format we write this, right? And how we write that? We write it like this: 255, 255, and another 255. And then 0. This 0 is coming from this 0, basically the host portion, and these 255s are representing the first 3 octet, which is the network portion. 255, 255, 255. And where this 255 coming? Like this. We know the 2 power table, right? 128, 64, 32, 16, 8, 4, 2, 1. And each bits, we write it like this: 1, there are total 8, right? 3, 4, 5, 6, 7, 8. Let's say this is for the first octet only. I am writing it like this for the first octet for 192. Now if you add all of these, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2, 1, you will get 255. This is how we come up with this 255. Understood? Then we move on to the next octet for the 168 octet. Okay. Again we put it like this, right? We write it like this for the 168 part, and again we get 255. Here it is 255. Then we will move on to the third octet for the 1 portion, and then again we put 8 bits like this, and then we get another 255. So this is essentially the same thing. We write in different formats. If you go to your personal computer and try to put like this, it will not take it. We have to put it this way. In some areas, like in the Cisco networking, in some interface it will take like this. So it depends. So mostly it will subnet mask is written like this. But for easiness, we know that /24 is like this: 255, 255, 250, and they both represent the network part of the IP addresses. Understood? So we have this 192.168.1 portion is our network part in this class C address, right? So our requirement is IT 50, finance 50, customer support 50, sales 50. So we need to allocate these 50 addresses for 4 departments from this part. Okay, now let me erase this. So for the first department, our network ID will be, we are going to use the same network ID given to us for the first department and also for the very first subnet. This is our network ID 192.168.1.0, same like what given to us. Okay, and then slash value we need to figure out. We have just figured out everything, right? So we know that the block size is 64. So if we write it like this, 128, this is a horizontal way, right? 64, 32, 16, 8, 4, 2, 1, and we know this is /24, means we used all the 3 octets and we need to start borrowing from the host portion. That's what we are doing. This process is basically that we are borrowing bits from the host portion, this 0 portion, right? Because up to here we have already used. We cannot borrow anything. There is nothing left. From these zeros, 8 zeros we have here, we start borrowing according to the requirement. So our requirement is 50 host each. That means 128 is too much, we don't need it. So 64. 64 means 2 bits borrowal, right? This is 1 bit borrowal. This is 2 bits borrowal, which means 24 plus 2 / 26. Correct? 2 bits borrowal, 24 plus 2 / 26. So our slash value is /26. In fact, for all remaining departments, same slash value will be used because it's 50 and you know it's going to be 2 bits borrowal, 24 plus 2, 26. Now the broadcast ID 192.168.1.64 is our block size, right? 64, but we can use the entire 64, so 1 minus 63, so we have to end at 63. So this is our network ID, this is our broadcast ID. So we already lost 2 IP addresses. So what's in between? .1 usable host or valid IP we can assign to the devices is .1 until 62, right? Dot 62. And subnet mask, okay, 255.255.255. We know this much, right? And it was 0 before. /24, it's like this, 255.255.0. But we have just borrowed 2 bits from this 0. Now it's no longer 0. And when it's no longer 0, we need to find the correct value. So that means we borrowed 2 bits. From these 8 zeros, we borrowed 2 bits, the first 2 bits. So the value for that is 128 and 64. So we need to add this 128 plus 64. What you get? 192. So therefore, this is no longer 0, right? This is 192. We have borrowed 2 bits from the host portion, and the value for those 2 bits are 128 and 64. So we add both 128 plus 64, you get 192, right? This is the new subnet mask and the new slash value. So we are ready with the IT department. We have everything. Now we can work the next one, finance. For finance, network ID 192.168.1. We ended at 63. So this will start at 64. Slash value same. And broadcast ID 192.168.1. Now again the block size is 64. So 64 plus 64 will give us 128, right? But can you go with 128? No, because 128 will start with the next subnet. We cannot use the entire 64. So we need to add 63. So 64 plus 63 will give us 127. Okay, or simply add 64 plus 64, if that's easy for you. 64 plus 64 you add, then minus 1, 127. Either way will work. Usable host, what's in between? Dot 65 until dot 126. Subnet mask, same like last subnet, 255.255.255.192. In fact, this will be the same subnet mask for all 4 departments. So we are actually ready with finance also. Now we can go for customer service. Customer service network ID will be 192.168.1. We ended at, for finance department, we ended at this one, 127. So this will be 128, right? Broadcast ID 192.168.1. Again we have to add 64, right? So 128 plus 64 is 192, but we cannot use the entire 64. So we need to add either 128 plus 64, 192, and then minus 1, 191, or just add 128 plus 63, you will get 191. Usable host, what's in between? Dot 129 until dot 190, correct? And subnet mask same, 255, 255, 255, 192. Now we have completed the customer service also. What's left is sales. Sales network ID will be 192.168.1. We ended at 191, so it's 192. And broadcast ID is 192.168.1. Again we have to add 64. The block size is 64, but 192 plus 64 is 256. We cannot go beyond 255, remember? So we need to minus 1, 255, right? Usable host dot 193 until dot 254. Subnet mask 255.255.255.192. So this is how you would work the requirements when you get it like this. You have equal length subnet mask, right, or fixed length subnet mask. So we needed 50 host each. So we broke it down like this for each department, and what given to us was a class C address with the default network bits, but with our requirement it changed to basically /26, and /26 is basically also written as 255 255 255, and then the borrowed bits 2 bits, and the value above is 128 for the first bit and then 64 for the second bit, right? So we have to add both 128 plus 64, you'll get like this 192. So this is the same calculation for all 4 departments. So we just increment by basically 63. So from 64, this ended at 63, this would start at 64, 64 plus 63 127, and then same subnet, the usable host what's in between. Then the next department, the next subnet will start at 128 because we ended at 127, and then again we have to add 63, 191 will get usable host, subnet mask same, and then the next subnet for the sales will start at 192 because we ended at 191. Broadcast ID again we need to add 192 plus 63 gives us 255, usable host what's in between, subnet mask same. Now we'll see this in the practical way in example, and we'll see how this one works. Okay, now we'll see this in practical in packet tracer. So what we'll do, we'll take couple of routers and let me add the serial interface. You need to power it off first, then add this, just slide it in to this first slot and turn the power back on, and simply make a copy of this just by pressing Ctrl. Okay, just press Ctrl. While pressing Ctrl, just click on it once and it will make a copy. Okay, and we'll get switches. We need 4 switches for 4 departments. Okay, 2 here and 2 here, like this we will design. Okay, and this is going to be our IT, this is finance, this is customer support or customer service, this is sales, right? Now let me connect this real fast. This is the WAN link. By the way, we would need 2 IP addresses each. We will figure that out later, but right now let me do this. Okay, now let me copy my network ID for IT and broadcast. So it would be this, and finance is this, let me do this like this, and customer service this, and then last but not least sales. Okay, we are done. Now we'll do IT. We'll start there first. Okay, so let's go here global configuration interface. So IT is connected to this G000, right? G00, no shut. IP address 192.168.1.0 is our network. So first one is 1.1/26. So 255.255.192. This time we'll configure DHCP and let's see if they get IP addresses from DHCP, and I will add PCs here. So IP DHCP pool, we need to create a pool and provide a pool name. So let's name it IT network 192.168.1.0 255.255.255.192 default router 192.168.1.1 DNS server. Let's say it is somewhere in the network. It is 192.168.1.50. Exit, save. Now we'll do it for finance, and it is connected to this G001 interface. G001 no shut. IP address 192.168.1.64 is the network ID. 65 is the first usable. 255.255.255.192. Exit. Now we'll create DHCP pool. IP DHCP pool and give a pool name. Let's make it simple. Finance. Okay. Network 192.168.1.64 255.255.255.192 default router same one 192.168.1.65 192.168.1.65 DNS server same 192.168.1.50. Now let me add PCs here. Now after that we'll verify whether they are getting IP addresses from this pool. Let me fast forward it. Now let's check. So by default it will be checked static. So we need to enable this DHCP by clicking this radio button, and it should get 1.2. So 1.1 we have given here at the interface. So this is 1.2. This should get, we have given 1.65 here at the interface. So this will be 1.66. And it is 1.66. So this is how the host will get IP addresses dynamically. This is how it's done out there in the field. Nobody is going to sit there and do it manually or statically. So now you know how to configure DHCP. If you have not watched the video, I'll provide the link right now. It will come. Once you learn that, come back and do this lab. It will help you. Like, it's very simple. Some basic commands we need to provide, like the ones we just did, like all these network. First of all, create pool name, network, default router, DNS server. That's it pretty much, and they'll get the IP addresses. And now let's go ahead and work this WAN link, and then after that we'll configure this side. So this needs two addresses, right? And let's say it's 10.0.0.0. That's address 10.0.0.0/30, and we'll work from this, right? So this will be 10.0.0.1 and this will be 10.0.0.2. Now let's go back here. So the WAN link needs two addresses. So we know that 2 to the 1 is 2. Minus 2 will give us nothing. So we cannot go with this. 2 to the second equals 4. Minus 2 will give us 2 valid addresses. So we can easily go with this 2 to the second. So if I write it like this, 128, 64, 32, 16, 8, 4, 2, 1, right? So 2 to the second 4. Where is this 4 here? It's all the way here, which means /24 here. This is the network portion. Now we are borrowing from the host portion. 1 bit borrowal 25. 2 bits 26, 27, 3 bits, right? 4 bits 28, 5 bits 29, and 6 bits 30. How 30? 24 plus 6, 30. So this is why we are getting /30, and to write it like this format, we need to add all the converted bits. The value for all the converted bits is 128, 64, 32, 16, 8, and 4. So we need to add all of this and we'll get 252. We will get 252 if you add all of this. So let me 19 actually 10.0.0.0, right? Network ID /30. Broadcast will be 10.0.0.3, right? Because block size is 4, but we cannot use the entire 4, so -1 3. Usable is basically .1 and .2. Subnet mask 255.255.255.252. So we are ready. We have the slash and broadcast ID, subnet mask. So what we'll do, we'll go to this interface S010, interface S010, no shut, IP address 10.0.0. First available is 1, 255.255.255.252. Exit, save. Now this side, same S010, mobile configuration interface S010, no shut, IP address 10.0.0.2, 255.255.255.252. We are done. Now we'll configure the DHCP pool for this side. So we'll start with this customer service. Customer service is connected to this G000, this line here. Interface G00, no shut, IP address 192.168.1.128 is our network. So first usable is 129.255.255.255.192. Now we'll configure DHCP, IP, DHCP pool, and we need to provide a pool name. Go with customer service itself for easiness. IP, DHCP pool, we cannot have space, that's why it's like this. Just put CS, okay, and network 192.168.1.128.255.255.255.192. Default router 192.168.1.129. The interface address we have just given 192. No, we don't need subnet mask, okay, just default router. DNS server, we can use the same. If we use the same, we need to provide IP helper address. So we'll just use a different DNS server. Let's say there is another server in this area somewhere. So that would be 192.168.1.100, right? The other one was 1.50. Now we'll do it for the sales side. That is connected here, G001, interface G001, no shut, IP address 192.168.1.192 is our network. 193 would be the first available. 255.255.255.192, right? Now exit and we'll create DHCP pool, IP DHCP pool, pool name, sales, network 192.168.1.192, 255.255.255.192. Default router same 192.168.1.193, right? This interface address we have just given. DNS server 192.168.1.100. Now we'll see if these two PCs are getting IP address. So let me add PC here, connect them. Okay, let me fast forward. And now this one should get 1.130. 129 we have given here for the customer service. So this would be 130. This should be 130. And it is getting 130. And this side 193 we have given at the interface, so it should be 194. Okay, 194. So we have completed this lab. Hopefully it helped somewhat. This is FLSM and we had the equal requirements of 50 hosts. So we have figured out everything here, right? And basically we did the theory part and also completed the practical, and we configured DHCP to allocate the IP addresses for this host. So everything is working fine. So our lab is a success. So that's it. We'll see some other concept in the next video. If these videos are helping you in any ways, please consider subscribing. Give me a thumbs up. Other than that, I'll see you in the next video. Until then, stay tuned. Thank you and good day.